Okay, this is part 2 of the tutorial. We have the image sequence rendered and it's in the right folder. Now we're going to Boujou to match move it. We go to import image sequence, we go to drive E, we go to clip, we go to sequence, and we select the first image of the sequence and click open. Oh, excuse me. Okay, now you'll see it says 24 frames a second, but when we click apply to actually add this footage to our project in Boujou, it will change to 25. So all you do is switch it back to 24 and click apply again, and now it's all good. Start from frame 0, end on frame 268 by one frame at a time. Okay, now we click close. Now we go to track features. Let's just leave everything exactly to default and click start. Now, as you see, it's putting a crap ton of little red crosses on the screen, and it is tracking differences between one frame and the preceding frame, and the little yellow tails that some crosses have denote motion of the tracked point, the tracked image difference, where it has calculated it moved from and to. So, while that is working, I could sing Mary Had a Little Lamb, but I don't think it'll take too long to do. The only thing that slows me down is I wish I had a faster processor, but I don't know. 3820 is okay, quad core with hybrid threading, so it looks like 8. So it's running okay. What I need is a Xeon in here, and it'd just blip through it. It would be so quick. Just the same. Not to mention the images are stored on a platter hard drive rather than my solid state drive, so I want to prolong the solid state drive's longevity, so it's okay if I have a trade-off of a little longer to access the image data. Okay, so now this is done, and if we scrub to the timeline, let's bring it back to the beginning and hit play. We'll see that we have points jumping in and out. That's okay, but everything that stays pretty much is nailed down to the image, like all of these that are along the dotted line in the middle of the road here and here, and some of the geographic features of the buildings and corners and so on over here. So, okay, that's good enough for now. We'll click stop, go back to the beginning. Okay, we want to go to, now that it's tracked, we want to go to camera solve. We will leave this box unchecked because there are no solves to delete. We want to leave both of these boxes unchecked. Radial distortion, I'm not sure exactly what that will help with, but I know it works fine without it, so don't check it. Optimize camera path smoothness is allowing the software to pre-calculate camera motion based on the previous frame's motion, and if you have a sudden movement that is not part of its calculation, it can throw the motion off. So you leave this unchecked, and that way it just calculates the motion from the data it actually has. We click start. It should be fairly quick. 99, zip that. Okay, now if we click play, we have a nice set of dots, yellow and blue, and everything seems fairly nailed down to the footage in the back. Now you'll notice the movement of the trucks and the car on the road. They do not have dots because they did not enter into the calculation because they moved in relation to the rest of the footage. So that's okay. Okay, back to the beginning. That looks like it's okay. Now we go to scene geometry. Now keep in mind we're operating in 3 coordinates. Z, which is from the front to the back. That means towards the camera and away from the camera. And X, which is left and right. And since it's really arbitrary, we're just going to line up along the edge of this red building here, which is okay because I have some dots here and here that I can use to line up. So, first thing, add a coordinate from a hint. We will make it the z-axis. We will choose this dot and hold control down and click that dot. So now 2 are selected. 2 are currently selected. 2 are required. Connect to selected. Okay, now we're going to add another one. And we're going to make this one an x-axis hint. We will select this dot and this dot. And we will say connect current. 2 are selected, 2 are required. So we click connect to selected, and now we have our X and Z coordinates figured out in our scene. Now we want to start, we have all CG scenes have an origin, so we're going to make it right by the thing that we want to do. We'll stick it right there at the vehicle of the origin point for our scene. And we will choose connect to selected, and then a couple of times we'll click update coordinate frame because sometimes one just doesn't do it, and then we click close. Alrighty, now since this is tracked and the coordinates have been defined for the scene, now we go to export, camera solve. Now, from top to bottom, when you export a camera, you want to work this page from top to bottom. Where do you want to save it? Well, I want to save it on the 2 drive. I want to go to the tie clip. I want to go to the C4D scenes. And we will call this match move. And it'll be named match moved C4D. And I'll click save. That just sets the name. Now, camera solve 1, sequence 1, we want to make sure it's on Cinema 4D type scene. Now, down here, we want to use format default for start index and null size. Don't know what all those words mean, but I know you want to change that to 0. And you want to change the scene scale to 100. And then click save. Now you see the blue flash over here. That means it's already done. It exported the scene with this information and alignment axes registered. So that's done, and we're done with Boujou. So I can minimize this. And this, the next part will be C4D, and I'm going to get the match move set up, and then I'm going to take a few minutes to model a building and show you kind of what process that goes through. So this is the end of part 2.